Hello everyone, welcome to Easy Ganit. My name is Samir Sardana. So we are discussing this 200 must do coin question for SNAP. And the next topic that I'm going to pick for you people is permutation and combination. A very important topic for SNAP exam point of view. You can look at the previous year questions of SNAP. You'll see that every year there are 2 to 3 questions of permutation and combination. Very important topic for SNAP exam. So guys, let's start. So here's the first question. I'll be picking a best question of permutation combination that help you understanding all main concepts which are relevant for SNAP. Here's question number 1. The theory part will be discussed along with the discussion of the question, guys. Theory के जो basics हैं, questions के साथ-साथ I'll try to explain. In how many ways can 6 people be arranged in a row when 2 of them are adamant about standing at either extreme position and another 2 person are adamant about standing in the middle? So guys, total number of people are 6. 1, 2, 3, 4, 5, and 6. In permutation and combination question, the first thing that you're supposed to do is to satisfy the given condition first, right? Now the conditions are the 2 people who are adamant about standing at the extreme position. So guys, if I say that I have these people A, B, C, D, E, and F. Let's say these are the 6 people we have, right? Now, out of these 6 people, 2 people are adamant about standing at the extreme position. So let's say that A and B are the 2 people who want to sit on the extreme position. So if A is on first, B has to be in the last position. If B is on first, then A has to be at the last position, right? And then 2 people are adamant about standing at the in the middle. So let's say C and D are the 2 people which want to sit in the 2 middle chairs. So now I'm automatically left with 2 persons, E and F. So there are only 2 possibilities for E and F, right? For these 2 chairs, right? Now I see that A and B can change their position among themselves. This can be done in 2 ways. E and F can also change their position among themselves. This can also be done in 2 ways. And C and D can also change the position among themselves. And this can also be done in 2 ways. So 2 into 2 into 2, answer will be equal to 8. This would be the correct answer, guys, right? 8 is the correct answer. Very easy and very simple question. In a group of 12 people, 5 speak on French, 3 speak only Spanish, the rest speak both French and Spanish, right? So I have 5 people speaking French. F1, F2, F3, F4, F5. 3 speak Spanish, S1, S2, S3. And the rest speak both French and Spanish, FS1, FS2, FS3, FS4, right? 5 plus 3. Yes, 5 speak French, 3 speak Spanish. The rest of the 4 people speak both French and Spanish. Now, in how many ways can the 12 people be arranged in a row such that all those who speak only French are together? So these are the people who speak only French. I want all of them to be together. So I would treat all these 5 people as a single unit, right? Similarly, all those who speak Spanish should also be together. So therefore, I'll also treat them as a single unit. People who speak French and Spanish, they may or may not be together. It's not given that people speaking French and Spanish should be together. So I will treat them as individual units. So this is 1 single unit. This is 1 single unit, 2 unit. And then we have 3, 4, 5, 6 units in total, which we are supposed to arrange. Now, 6 units can be arranged among themselves in 6 factorial ways. And these 5 French people can be arranged among themselves in 5 factorial ways. These 3 Spanish people can also be arranged among themselves in 3 factorial ways. This would be the correct answer of the question, right? Question number 3, in a group of 10 people, 4 speak on French, 3 speak only Spanish, rest speak both French and Spanish. In how many ways can 10 people be arranged in a row such that all those who speak only French are together, and so are all those who speak only Spanish? Further, all people should be able to converse with both their neighbors. Now, this question is almost similar to the previous question, but one condition is there that the people who are sitting together should be able to communicate. Now, what is the problem with the previous question? You see that if these you see that here the condition that 2 people should be sitting together should be able to converse with each other was not there. So if I'm doing the arrangement of first 5 French people and on the next on the next 3 chairs, I'm asking 3 Spanish people to sit, then you see that both of these 2 people will not be able to converse with each other. But that's not a condition that I'm supposed to satisfy in this question. But in this question, I'm supposed to satisfy the condition. So therefore, this particular arrangement that I did in the previous case will not be valid for the third case, right? Because I have to satisfy the condition that the people sitting together should be able to converse with each other. Now we have only these 3 people who are speaking French and Spanish, who can speak both with French people as well as with Spanish people. So therefore, I'll be first asking these 3 people out of 10, 4 speak French, 3 speak Spanish. There are 3 people who speak French and Spanish both. So I'll first arrange these 3 people on 3 chairs, right? Now, how many spaces I have how many spaces I'm left with between these 4 people? Now here, if French people is coming to sit, you see that this person will be able to speak with this person because this person is speaking both the language. And if Spanish person is coming to sit over here, then this Spanish person can speak with this person as well as this, because both of these 2 people can speak both the languages. So once I arrange the people, those students, those persons who can speak both the language, then out of these 4 spaces, what are these four spaces? 1, 2, 3, 4. I can pick any one space, right? So first, I'll arrange these 3 French and Spanish speaking people, which can be done in 3 factorial. Once I'm done with this, rest of the 4 position, out of the rest of the 4 position, I need to pick one position first for French speaking people. Now let's say that I have selected this position. Now, in how many ways 4 French speaking people can be arranged on this space? It can be done in 4 factorial. Then I will be left with how many more spaces? Once all French people are sitting here, I'll be left with 3 more positions. Now I need to pick only one space for Spanish speaking people. Once I picked a space for Spanish people, these 3 Spanish speaking people can be arranged among themselves in 3 factorial. So final answer would be 3 factorial multiplied by 4 multiplied by 4 factorial multiplied by 3 multiplied by 3 factorial. That would be the correct answer, right? You can just do the calculation now. This is 12 into 4 factorial into 3 factorial square. This is the correct answer to the question, right? Look at the question number 4. In how many ways 8 cars we parked in 8 parking slots in a row such that there are exactly 4 cars between 2 specific cars? I have 8 parking lots. 1, 2, 3, 4, 5, 6, 7, 8. Now let's say that let's name the car as A, B, C, D, E, F, G, and H. These are the 8 cars that I have. Now between 2 specific cars, I want exactly 4 cars. Now let's pick these 2 specific cars because it says that there are 2 specific cars. So let's say the specific cars are A and B. I want 4 cars between these 2 specific cars. So if I'm parking A over here, then B will be over, then B has to be parked over here, right? If B is over here, then A has to be over here, right? The second case would be if A is here, then B has to be here. Or if B is here, A has to be here, right? Third case would be if A is here, then B would be here. If B is here, A would be here, right? So I have 3 cases, right, in which I can make sure that between these 2 specific cars, I have 4 cars in between, right? Now, in this particular case, these 2 cars, A and B, can be arranged in 2 factorial ways. That is in 2 ways multiplied by rest of the 6 cars. There is no condition that I'm supposed to follow. So rest of 6 cars can be arranged among themselves in 6 factorial ways. Similarly, in this case also, the total number of arrangement is 2 into 6 factorial. In this case also 2 into 6 factorial, right? So add them up, you will get your answer as, if I add them up, the answer would be 6 multiplied by 6 factorial. Option 1 would be the correct answer to the question. Question number 5, there are 8 rows on a rowing boat. They have to be seated such that 4 sit on the right hand side and 4 on the left hand side of the boat. 3 of the rows insist on sitting on the right hand side and another 2 of them insist on not sitting on the same side. In how many ways can the rows be seated? So guys, 1, 2, 3, 4. We have 4 seats here and 4 seats on the other side of the boat, right? Let's say that let's say that this is the board, right? This is the board that we have, and there are four seats here, four seats on this side, right? Now, questions condition. Satisfy the condition first. Three of them insist on sitting on the right hand side. Let's say A, B, C are the people who insist on sitting on this side. Another two of them, let's say E and F are another two of them who insist on not sitting on the same side. Not sitting on the same side means if E is here, F would be here. And if F is here, E would be here, right? And there's no other condition. See that, can I change the position of ABC? No, I cannot change the position of ABC. ABC has to be on this side only. I cannot get ABC on the left-hand side of the board, right? Let's say this is the left-hand side and this is the right-hand side of the board, right? Can I change the position of E and F? Yes, but they are not supposed to be on the same side. If E is here, then F would be here. If F is here, E would be here. And the rest of the persons, right, would be G, H, and I. E, F, G, H, I. Right. Let's say G, H, I are the rest of three people, right? Do I have any condition of these three? No, I don't have any condition of these three. But can these three people be asked to sit on the right-hand side? No. Why? Because we don't have any space for these three people, right? Okay. So guys, tell me, in how many ways you can do the arrangement of A, B, C, and one of these people, F or E? This can be done in 4 factorial. Similarly, these 4 people can also be arranged among themselves in 4 factorial. But you see that E and F can change their respective position with each other. So they can also be arranged among themselves in 2 factorial ways. So total arrangement would be 24 into 24 multiplied by 2. That is 576 multiplied by 2, 1152 will be the correct answer to the question. That is option number 3, everybody. Moving on to the next question. Let's move on. Question number 6. A new flag is to be designed with 6 vertical strips using some or all of the colors yellow, green, blue, or red. Okay. So guys, we have to design a flag with 6 vertical strips, right? With 6 vertical strips. 1, 2, 3, 4, 5, and 6. These are the 6 vertical strips that we have. And we have an option of using any of the colors, right? Either it can be yellow or green or blue or red. The condition that I'm supposed to satisfy is that no 2 adjacent strips should have the same color. So guys, tell me, this first strip can be filled with how many colors? I can use yellow color or green color or blue color or red color. Any color can be used here. So this can be done in 4 ways. But then I need to make sure whichever color I'm using on this strip, the same color should not be used on this strip, because 2 adjacent strips should not be having the same color. So if this can be filled in with 4 colors, we have only 3 options, 3 color options for the second strip. Similarly, out of 4, whatever color has been used here, same color cannot be used over here. So I'll be left with 3 options for here, 3 here, 3 here, 3 here. So total, you can see that this will be the answer. This is 3 power 5 multiplied by 3. Now, if you look at it, 3 power 5 multiplied by 4 is nothing but 3 power 4 into 3 into 4, which can be rearranged as 3 power 4 as 81, 4 into 3 is 12. 81 into 12 is the correct answer of the question, everybody. Moving on to the next question. Question number 7. Okay. 5 boys and 5 girls are to be arranged in a row. Find the difference with the number of possible arrangement when 2 girls are sitting together and when boys and girls are alternate. Okay, so we are supposed to find out the difference in the number of ways. Okay, see guys, if 5 boys and girls are supposed to be alternate, the funda is very simple. If they have to be alternate, first I will arrange the boys, right? B1, B2, B3, B4, B5. In how many ways I can arrange the boys? It can be done in 5 factorial. Because I want boys and girls to be alternate, now I'll ask the girls to sit between these spaces between the boys, right? How many spaces I have? 1, 2, 3, 4, 5. 5 spaces, 5 girls. It can be done in 5 factorial ways. But then there can also be the case when I'm asking girls to sit together first, right? Let's say that I'm arranging first the girls, right? G1, G2, G3, G4, G5. And then between these spaces, I'm asking the boys to sit. So 5 girls again can be arranged in 5 factorial ways. And then boys can be asked to arrange in 5 factorial ways. So total would be the addition of these 2. And this would be 2 multiplied by 5 factorial multiplied by 5 factorial. So if I want boys and girls to be alternate, the total number of possible ways will be 2 multiplied by 5 factorial multiplied by 5 factorial, right? Now, the second is a case when I want boys no two girls to be together. If I want no two girls should stand together, the first thing is that I don't want girls to be together, right? So I'll first arrange the boys on these 5 chairs, B1, B2, B3, B4, and B5. Now, these 5 boys can be arranged in 5 factorial ways, right? Now, how many spaces I have? I don't want girls to be together. That means between any 2 girls, there has to be at least 1 boy. Between any 2 girls, there has to be at least 1 boy if I want no 2 girls to be together. So how many spaces I have? 1, 2, 3, 4, 5, 6. We have total 6 spaces for girls, right? Now, out of these 6 spaces, right, I am supposed to choose only 5, right? I can choose any 5 spaces for girls multiplied by, and the girls can be asked to sit in how many ways? 5 factorial. So the total number of arrangement would be 6 into 5 factorial into 5 factorial when no 2 girls are together. We are supposed to find out the difference between these 2 cases. The difference between these 2 cases will be 6 into 5 factorial raised to power 2 minus 2 into 5 factorial raised to power 2. Now, if you take 5 factorial raised to power 2 as common, 6 minus 2 will be 4. This is the correct answer, which is option number 3, everybody. Moving on to the next question, let's have a look at question number 8. In a staircase, there are 4 steps. A person can take 1 step, 2 step, 3 step, or 4 steps. In how many ways can he reach the top? So guys, there are 4 steps, right? Okay. Okay, 1, 2, 3, and 4. That's it. These are the 4 steps of the chairs, right? 4 steps, right? In a staircase. Now, a person at a time can take 1 step, 2 step, 3 step, or 4 step. We are supposed to find a total number of ways in which he can reach the top. See guys, you just have to see the total possible arrangement. Case 1 would be the case. Case 1 is that case, right? Look at the case 1. If he's taking only 1 step at a time, right? 1, 1, 1, 1. He took 1 step here, then he took 1 step here, 1 step here, 1 step. There's only one possible way, only one way, if he's taking only 1 step, right? At a time. There is also case 2, where he is taking 2 steps and then taking 2 steps of 1 each. Now, there can be a multiple arrangement. You see that 2 plus 1 plus 1, total number of steps will be 4. He will reach at the top. But whether he's taking this step first or this step first or this step first, we don't know. How many possible arrangements are there? Total number of arrangement would be 3 factorial by 2 factorial. Why divide by 2 factorial? Because these 2 are the same steps, right? So this will be total 3 ways. Case 3 would be the case. Case 3 would be the case when the person will be taking 3 steps and the 1 step, right? So this can be done in arrange 2 factorial ways. Whether he'll take 3 steps first, then 1 step first, then 3 steps. So there will be 2 more ways, right? Case 4 is the one where he's straight away taking the 4 steps, right? Because he can also take 4 steps in one go. So this can be done only in one way, right? Then there's another case 5 also. You might be taking 3 steps, right? Or so 3 plus 1, 4, 4 plus 2, 6 plus 1, 7, right? There can be one more possible case. We have taken all 4 steps together. A case of 3 plus 1. Okay, yes, the one more case would be 2 plus 2, right? He's taking 2 steps first, then 2 steps again. So this can again be done in 2 factorial by 2 factorial. That is one way on. So total number of ways of reaching at the top would be 1 plus 3 plus 2 plus 1 plus 1. That is a total 8 ways in which he can reach at the top. First would be the correct answer to the question. Moving on to the next question, everybody. Question number 9. If I write all the numbers from 100 to 1000, for how many times I'll have to write the digit 2? Okay. So guys, I'm supposed to write down all the numbers from 100 to 1000, right? From 100 to 1000, that means I'll be writing only 3-digit numbers because 1000 is the first 4-digit number. Now, if I'm fixing 2 here, I'm supposed to write down how many times I'll be writing down the digit 2, right? If I'm fixing 2 here. Now, this place, you see that, can be filled in how many ways? 10 ways. This place can also be filled in 10 ways, right? So there'll be total 100 numbers, right? That you will be able to make. Then, if I'm fixing 2 at this place, then you see that this place cannot be filled with 0 because I'm supposed to write down numbers with 3-digit numbers. So this place can be filled in 9 ways, and this place can be filled in 10 ways. There will be total 90 such numbers, right? And then if I'm fixing 2 at this place, then this place can be filled in 9 ways, and this place can also be filled in 10. Then can be filled in 10 ways. So there'll be total 90 more numbers, right? That's it. I'm not supposed to write down any 4-digit number. So only 3-digit numbers are supposed to be made. So 2 can come over here, or 2 can come over here, or 2 can come over here, right? So with all the possible cases, if I'm putting 2 here, there are total 100 numbers. If I'm fixing 2 here, there are total 90 more numbers. If I'm fixing 2 here, there are 90 more numbers. So total number of times I have to write the digit 2 would be 100 plus 90 plus 90. That means it would be 280. 280 would be the correct answer of the question, right? In how many ways can 8 letters be put in 8 differently addressed envelopes such that exactly 5 letters go into the wrong envelope? See guys, if you have to do the wrong arrangements, or you can say that de-arrangement, right? If I want n envelopes to go in n letter boxes, and all the letters should be going into the wrong boxes. N letters in n boxes and all the letters in wrong boxes, then the number of dearrangements, number of derangements, will be equal to n factorial into 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial, and so on, 1 upon n factorial, right? Plus or minus depending upon the value of n, right? Now in this case, I want out of 8 letters, I want 5 letters to go into the wrong place, but I want 3 letters to go in, 3 letters to go into the right place. So out of 8, I can first select 3 letters which I want to put in the right boxes. So let's say that there are 3 letters that I have selected because I want them to put in right boxes. There's only one way to put them in right boxes because there's one right address for every right envelope, right? For every one envelope. So 8C3 is the right. 8C3 is a number of ways in which you can put 3 letters to the right addresses. But then I also need 5 envelopes to go to the wrong addresses. So then you see that n factorial. 5 letters are supposed to be sent to the 5 addresses, but all should be gone to the wrong address. So straight away, just put the value of n as 5 factorial. Right, this would be 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial minus 1 upon 5 factorial. This is what you have to solve, right? This 8C3 is same as 8C5. And if you solve this whole thing, right, I'm sure you will be able to do the calculation by yourself. This will be 44. So the answer to the question will be option 1, everyone. Okay. This is question number 10. Question number 11. What is the possible number of ways to select 3 numbers from the first 15 natural numbers such that the selected numbers are in arithmetic progression? See guys, the total 15 natural numbers that I have, right? Out of these 15 natural numbers, I want to select the numbers. 3 numbers is what I'm supposed to select, but all 3 numbers should be in arithmetic progression. Let's say that 3 numbers I have selected out of first 15 natural numbers is ABC. If I want them to be in arithmetic progression, then you see that B has to be the arithmetic mean of A and C. That means A plus C should be equal to 2 times of B, right? A plus C should be equal to 2 times of B. Is it clear? Now you see that this right hand side is an even number. If this is an even number, the only possible way to get all these 3 numbers to be in arithmetic progression, I have to make sure that A and C has to be even number. It's a summation of A and C has to be even number. The summation of A and C can be even number if both of them are odd, because odd plus odd is even, or both of them has to be even because even plus even is also equal to, right? Now, if I want the number to be, both numbers to be odd, how many out of 15 natural number, 15, 1, 2, 3, up to 15. See that out of these 15 natural number, I have total 8 odd values and I have total 7 even values, right? Now, out of 8 odd values, right, I need to select 2 odd numbers. This can be done in 8C 2 ways, or I can select both of these 2 numbers as even, and this can be selected out of any of these 7 numbers. So 8C2 plus 7C2 is my answer. So just solve it. This is 8 factorial by 2 factorial multiplied by 6 factorial. 7 factorial by 2 factorial into 5 factorial. Right, now 8 factorial, this is, you can see that 8 into 7 into 6 factorial and 6 factorial get cancelled. 24. This is 28. And this is 7 into 6 into 5. This get cancelled 3. So this is 21. So 28 plus 21, the final answer would be 49. This can be done in 49 ways. So option 3 would be the correct answer to the question, right? Next is the question. 12 persons are sitting in a row. Find the number of ways of selecting 5 persons such that no 2 of them are consecutive. See guys, 12 persons are there. Let's say that A, B, C, D, E, F, G, H, I, J, K. These are the 12 persons. I want, find the number of ways. I want to select 5 persons out of it in such a way that no 2 of them are consecutive. No 2 of them are consecutive, right? So guys, let's say that I have selected, person B, D, G, I, and K. I see that if I go for this selection, no 2 of them are consecutive. This is one of the possible selection that I should be going. So what you should be doing is, you see that if I select these persons, right, the rest of the persons that I'm left with would be A, C, E, F, H, J, L. That means I should be basically the answer to the question will be same as arranging B, D, G, I, and K in such a way so that none of these 2 people are consecutive, right? The number of ways of arranging B, D, G, I, and K in such a way that no 2 of them are together or no 2 of them are consecutive, right? If I want B, D, G, I, K to be arranged, right, so that no 2 of them are consecutive, I need to arrange them among the spaces between these, right? How many spaces I have between these? The total number of spaces 1, 2, 3, 4, 5, 6, 7, 8. So out of 8, select any 5 spaces and arrange them in how many ways? You can arrange them in 5 factorial ways. So this is 8 factorial by 3 factorial multiplied by 5 factorial, right? So basically 8C5, right? 8C5, 8 into 7, 8C5. This is 8 factorial, 8 into 7 into 6 multiplied by 5 factorial, divided by 6 into 5 factorial. That's it, guys. We don't need to arrange them, right? We just need to select them. We need to select the spaces for them, right? And these can be any of the spaces. We don't need to arrange it, right? 8C5 will straight away be the correct answer of the question, which is 8 factorial by 3 factorial into 5, 8 into 7 into 6 into 5. This get cancelled, 6 and 6 will get cancelled. Final answer will be 56, right? Why we are not supposed to arrange them? Because ultimately we are selecting, right? So once I select the space, I arrange these 5 people, right? Five letters, right? And because I'm selecting the spaces out of these spaces where and between these spaces already A, C, F, H, J, L are present. So no 2 of them will be consecutive, right? This is what I have to make sure. That's it. So 58C5 will be the correct answer, and answer will be 56. So guys, these are the 12 questions that I wanted to discuss with you in the chapter of permutation and combination, right? More questions on PNC will be uploaded soon. And till now, we have covered 12 standard questions of PNC, which I'm sure will be helpful in SNAP exam. Subscribe to the channel, share it with all of your friends. Till now, we have covered now around 70 questions of 200 must-do quant questions for SNAP. Rest of the questions will be uploaded soon on the channel. Subscribe to the channel. You can also watch 100 reasoning ability questions for SNAP and OMATs available on Easy Grid by Slate. Thanks a lot, guys. Thank you.